Hey folks, welcome back. This is Andy and this is the Pork Rolls Almanac. Today we're going to be talking about cows and bees with Dr. Ryan Shmid and Katya Busenitz from the Ecdysis Foundation. In this conversation, we talk about the relationships between grazers and bees, both honeybees and native pollinators. I think you guys are going to really enjoy this conversation as it ties together a lot of the different subjects that we've talked about over the last 3 years. So take a listen and let us know what you think. Katya and Ryan, thanks so much for coming on to talk. Please introduce yourself.
Hi, I'm Katya Busenitz. I'm a master's student studying honeybees.
And I'm Ryan Shmid. We're both at Ecdysis Foundation here, and I study dung beetles and beneficial insects for ranchers.
I gotta ask first, for you, what came first, the cattle or the bees?
That's for you. Oh, so I kind of got thrown into bees. I never worked with bees before, and I came out here to Ecdysis, where we study agroecology and kind of like regenerative agriculture. And our boss, John, he kind of just threw me out there. He was like, go work with the bees. This is a hive tool and this is a suit, you know? So I got thrown out there. So for me, the bees came first. And then Ryan's been doing ranchland stuff for a while.
Yeah, I grew up on a small cow-calf operation in Northwest Iowa. And so that's where I first got interested in cattle and livestock management, and took a weird turn studying insects for quite a while. It's been kind of bizarre that it came back full circle now. Now I can combine those two things together. And now we're looking at bees.
Yeah, that's awesome.
Yeah.
You went from the biggest animal on the landscape to the smallest animal on the landscape and then brought them together.
Yeah.
And they're both connected. That's the coolest part.
Yeah.
Yeah, that's, I guess it's like one of those things that's like not totally unsurprising, like everything's connected. And, you know, even from like a very fundamental level, you think about like, okay, you need insects to break down cow dung. So like there must be a correlation between the landscape or the ruminants on the landscape and how that impacts the diversity of the bugs on the landscape. As a farmer who does mob grazing, and also I have some bees, it makes a lot of sense when you start thinking about it. My first thought was really around this idea of, okay, if I'm trying to make each better, what's the best option? And around cattle, I would imagine like letting grasses grow a little bit bigger might make it reduce bloat with like forbs, and allowing them to flower would provide some nectar for bees. But I'm assuming there's probably a lot more to this than like something as simple as that. So I guess whoever wants to talk about it, you know, is that about accurate, or is there a lot more going on?
Yeah. So like, yeah, at a 30,000 foot view on the system, that's pretty accurate. But you like to mention it's very complex. So these grassland systems are complex, and there's actually a lot of interactions. If we just want to focus on the three players of bees and cows and grass, there's a lot of interactions that they have with one another. And typically, that's kind of done indirectly through the soil, the plants, how you touched on cows poop, insects start the nutrient cycling through the soil, helps plants, bees. But there's some interesting stuff to it. So let's use that as our model, I guess. Cow feces, it's rich in nutrients. And if anybody cares to know, when a cow pees, it's about 95% water, 2.5% urine or urea, which is nitrogen, and then the rest is minerals, salts, hormones, enzymes, other random things in there. And dung is 80% water. And then there's a lot of bacteria, nitrogen, calcium, phosphorus, potassium, magnesium, sodium, that kind of stuff. And if you want to, like, just as a sidebar, maybe we can circle around to it sometime, but like when you start amassing that for like a herd, there's a lot of nutrients that are going on the ground, and you can look at it from a national level, and it's a huge issue that we have to deal with, actually. But that's a story for another time. So let's get back to our bees, cows, and grass. So cows poop, put it on the ground, and then we have our arthropods that really take advantage of that. And the reason we focus on dung beetles first for a lot of ranchers in our area is because they actually open up that nutrient. Because cow pat sits on the ground, it actually gets like this seal. If you ever looked at one, after a few days, it seals over. It has like a crust on it, a little bit of seal. And the flies get there really fast, like within an hour. They're on a cow pat within minutes usually. they can do that because it's still wet, it hasn't sealed over. But a lot of other insects can't get in once it's sealed up. So dung beetles come in there, and there's a big kind of burly guys that basically make a tunnel highway network through your cow pie. That opens it up for all these other beneficial insects like staff linen beetles or rove beetles. You've ever heard of those? Parasitoid wasps, and a whole host of other kind of weird beetles and that sort of thing that come in there and help to control pests on that livestock, fly pests usually, and then also break down those nutrients. And basically what they're doing is they're creating more surface area for the next stage in this process, which is for the earthworms, nematodes, bacteria, fungi that recycle it into your soils. Plants take advantage of those available nutrients rather than letting it sit on your ground and kind of oxidize out a lot of that nitrogen, which translates to more nutritious plants for both bees and cattle. Because some of these grazing systems, after you do this, we see the plant community respond and soil community respond a lot differently. So Richard Teague and Urs Kruger, Sam Mosier have kind of showed some of this cool stuff where there's more carbon, nitrogen in your soil. The soil infiltrates water better, 2 to 3 times more forage biomass of the plant community, improved plant community composition, improved fungal and bacterial ratios in our soils. And then that in turn improves the forage quality for our bees out there. And there's some cool studies looking at like vermicomposting and how that improves actual bee health from improved soils.
That's awesome.
And then thus the cattle's or the bees can improve the forage out there for the cattle, and the cattle can keep improving forage for bees, and it's kind of this weird loop. So that was a long-winded answer. Sorry.
No. It was great. It raises like a lot of things that I wanted to, like as you were talking, there was like more questions I had for you. So the first thing I wanted to bring up, and it's more of a sidebar, is like in a lot of regenerative groups on like Facebook and things like that, you see a lot of farmers that have been farming for a long time who are like, hey, what's this thing in around the cow dung? I've never seen this bug before. And it's usually a dung beetle. And I'm curious, because I don't know the answer to this. Like, what are the prerequisites? Because I'm assuming like a lot of traditional farmers have cows and therefore have cow dung there. So why aren't they used to seeing this in a traditional management system versus like a regenerative system? Or do you think they're just being more aware of what's going on?
Yeah, I wonder if they're just noticing the bugs, Yeah. Because you found dung beetles everywhere, right?
Mm-hmm.
Even if you're managing the shit out of your land and and you've got a bunch of cows on one plot of land, like you're still gonna have dung beetles.
Yeah. Even a conventional system, I find dung beetles. I wonder, and this is just pure speculation on my part, if it's not because the regenerative ranchers or AMP or mob grazers, whatever you want to call them, it's because they're out there more. And they're paying attention to the biology that's going on in their land because they care about it, because they understand that biology is essentially what's making that system work. Like we just went through this whole thing of essentially a rancher. You could think of them as a nutrient cycling manager. And to make those nutrients cycle, they need the biology. So they pay attention to that.
Yeah.
That's my theory.
That would make sense. So I do want to bring up a couple other things that you've mentioned in your description of what was happening. So you talked about this idea of like how important it is for the dung to break down to return nutrients to the soil. You'd mentioned this idea that like it makes the plants healthier, which like I think everyone understands this idea of like if there's more nutrients, the plants are going to be healthier. Now, how does that translate into like, does it affect like the pollen levels in the flowers that are coming up, or is it just the plants are more resilient so they're flowering more?
It could be either one of those. Let's see, I can point to a study here from someone, Cardoza, back in 2012, where they kind of they did apply this vermicompost, and they were using cucumbers as their model system. They want to see any behavioral and physiological changes to the pollinator and flower and floral resources. And when they added that vermicompost, they found that one, it significantly increased the bumblebee, their feeding on those flowers, they had significantly larger and more active ovaries, which is a measure of nutrition. So the bees are getting some more nutrition from the plants. So the plants had to have more nutrition in them from this vermicomposting. And so that's kind of how you can see how it's working its way through the system.
Yeah, that makes sense because I know a lot of bees won't, they can essentially like sense the sugar content within the flowers, so they know whether or not it's worth their time to even harvest from them. Basically like a Brix scale for them. And it would make sense then plants that are healthier are probably producing more of those things that draw the bees in.
Yeah.
That makes a lot of sense, I guess. In terms of like application, are you guys actually like tell me a little bit about like what you're doing to see this in practice?
Yeah, so I was going to say that about the Brix. That's part of our study. We've got this 2-year study right now. We're trying to do it this summer. Again, we did it last summer where we took some of our beehives and we put them out at different locations where the ranchers are managing their cattle differently. So if they're continuously grazing or if they're grazing them like in a rotation. And then we're going out there and we're measuring plant biomass. We're doing floral counts. I'm looking at the bees. So I'm looking at the brood counts for the beehives. I'm looking at some weights, seeing if they're gaining weight, losing weight, sort of just like basic health metrics. And then Ryan's also doing rangeland stuff for those same locations.
How many years have you been doing it? Or are you still in the first year?
We have stuff from last summer that we haven't looked at as much as we want, because we were just talking about that. We're like, God, I wish that we could just like talk about what we did last summer and have actual results, because it was such a fun study. It was really cool.
Yeah, I'm super interested to see like the honey production comparisons to see if that kind of plays out at all.
Yeah, and I don't have any analysis done for that yet, but it does look like there's a pretty interesting difference. And we only did
like anecdotally?
Yeah, anecdotally.
Awesome.
I measured Varroa too, and something that I found that, this hasn't been like statistically verified or anything, but it kind of looks like the Varroa stayed lower at the rotationally grazed sites.
Really?
Yeah, which is interesting.
Yeah, and what did you guys do for maintenance on Varroa? Did you guys treat, or was it more of a natural and just kind of see what happens? Or
yeah, we're kind of trying to do like a natural approach where we don't treat for Varroa throughout the summer. This year I did do a treatment going into winter, just trying to save some hives, hoping that some of them make it. But that's the first time we've treated for Varroa.
That's awesome. I try not to treat, and I'm super into the idea of natural beekeeping, but it's I think what you're kind of getting to the point of is that you can't meaningfully naturally treat beekeeping or bees without addressing like the bigger ecosystem issues.
Yeah.
It's like one of those things like you always see in like various natural beekeeping groups. It's like, how do you get rid of ants? How do you do this? How do you do that? And you try all these different things and like none of them work.
Yeah.
I've seen like put mint above the hive or around the hive, or like cinnamon or like any of these other things, and like I've never had any of them work. So like there's a lot more going on, and it ties into this bigger ecosystem issue. So I guess to get back to my questions a little bit, I know you weren't just, or I believe at least you weren't focused just on like honeybees, but also like the local bugs in the ecosystem. Now, how did grazing impact that, or do you have any data on that?
We don't have data from last year.
With the pollinator community.
Yeah, with the pollinators.
Yeah. We have some previous studies looking at arthropod diversity in pasture grassland systems that we did 3 years ago in the southeast US. And interestingly enough, so we measured the dung community, the soil arthropod community, and then the foliar community. So what insects are up in the plant canopy. And we found that there's more diversity in the plant canopy arthropods when you're grazing them regeneratively or holistically, whatever you want to call it. And the soil community actually didn't respond as with more diversity to that kind of grazing treatment. But the functional guilds, so when we look at essentially when we group arthropods together by the jobs they're performing, so their guilds, they change quite a bit in the dung and the foliar community from your grazing. So you get more predators and less herbivores in a foliar community, which is fantastic.
Yeah, it would point to more cycling of the nutrients, right?
Yeah.
I'm really curious about the fact that you said there didn't seem to be much change in the soil. Do you think that's because it's a longer process for those changes, or do you think it's has to do with maybe the species, or I think about like cattle, for example, and I'm not sure what you were looking at grazing in the South, but cattle really aren't a good species for grazing in the southeastern United States. So it would make sense then that that maybe even doing a holistic grazing, or whatever term you might want to use, still wouldn't really produce like optimal results.
Yeah. Oh man, you struck at the thing that I've been thinking. I'm writing this paper right now, and I've been trying to figure out what's going on. Why isn't that soil arthropod community responding? And a couple theories I have on that. One, we've seen that soil arthropods usually respond differently to regenerative practices. They're a little slower. And I think it might be because they're generally less mobile than, they're crawling around in the soil most of the time. They're not going to move across to pastures as much, or row crop fields, as their foliar counterparts that are like grasshoppers and flies and other things that move around really well. The other thing that concerns me is maybe we're not measuring it correctly. And that's what kind of keeps me up at night. If we did something maybe we didn't capture what we needed to capture within that community correctly. And I think of things like mites and all those smaller critters that are making up that community in the soil that we usually don't measure. We measure mostly insects. But there's a lot of other things that are really important in the soil community.
Yeah.
Not 100% sure.
Hey, thanks for tuning in to the Poor Proles Almanac. This is Andy, reminding you that if you're looking for more content outside of the scope of the podcast, or sources, recommended readings, or ways to support us, you can find that at poorproles.com. Further, we've expanded our delivery into video content on our YouTube channel, where we're able to show step-by-step how to do many of the processes that we talk about within the podcast. We have also started a Twitch channel where we platform various folks on skills from DIY mushroom production to the various methods to keep land out of the hands of developers. Again, all this can be found at poorproles.com, and we look forward to seeing you over there. What species were you grazing? I'm assuming it was cattle, but was it anything else?
It was pretty much cattle on all the pastures, except for one rancher had some sheep that he was grazing with his cattle.
Did the results happen to be any different with those sheep?
Not really, which is interesting. You would expect it to be a little different, wouldn't you?
Yeah.
With those different livestock, so at least nothing statistically different that really jumped out at us.
Yeah, that's interesting. You talked about the bees being good for the grazing. So that's the side we haven't really talked about. We spend a lot of time talking about how grazing is good for bees, but not the other way around. I'm not sure who wants to talk about that a little bit, but I'm really interested because I'm struggling to have an understanding of that piece.
Well, I mean, it comes back to this whole looking at it as a system thing again. And I'm using honeybees because we can measure that. And, we've got a pretty standardized way of managing the colonies and measuring, health responses, if they're healthy or not. But the whole system, requires pollinators no matter what you do. And so this pollination is going to increase the health of the plant community. And then that's also going to, feed back into whatever's eating the plant community. So I think the connection is sort of just there in the system, if that makes sense.
Yeah, that makes sense.
And then for you, like you're working with sheep, right?
Sheep, chickens, ducks, turkeys, geese.
So like for your grazing plan, you've got your trees worked in, right?
Yeah.
So your fruit fall and stuff, pollination would be a part of the fruit set, which would also impact, how your grazers are eating in the fall, or, whatever time of year you put them under the trees. Yeah,
definitely. I could see that. That's one thing part of the reason why I got bees the first time was because I was not happy with the pollination rates that I was getting on my annuals. Mm-hmm. And I was like, I don't understand. Like, I've got these tons of flowers everywhere and nothing's fruiting. And I brought in bees and it didn't make much of a difference. What I think actually was making the difference is that there's a lot of spraying here for like West Nile virus. And I'm right near the highway. So like that's where they spray. So I'm just like right in the dead zone.
Yeah.
So we've had a little bit of improvement. And I think some of that is because of the land management here. I think we're kind of like a little bit of an oasis now in like suburban hell. So I think we draw a lot of interest that way, but it's been a slow process, which actually it makes me wonder about like with the work you guys are doing. I'm assuming not all of the sites, or probably none of the sites, if you're looking for like that standard point to start this research, were doing mob grazing beforehand. So I'm interested a little bit about like how you saw over the course of a year or 2 or 3 years how the ecosystem changed from these practices in terms of like the general diversity that you were seeing. And is this something people, if someone were to buy a farm today and it's like just a traditional farm, how long does it take to start kind of seeing those impacts?
That's an awesome question. That's something we've been doing like a ton of research on for years, trying to figure out how long does it take to transition, into a functional ecosystem.
Mm-hmm.
So
yeah, we're starting those studies now. Typically, in our previous studies we've been talking about, we select systems that have been in place for 5 years because we want to see the effect of that system and not the effect of transition. Because you hit the nail on the head there. There is a transition period. It takes a few years for biology to respond and come back to an area. And if you look at some of Fred Provenza's work and some other folks, they're saying 3 years. And anecdotally, after talking to a lot of farmers or ranchers in this area of the Northern Plains, in our climate, it takes minimum 3, sometimes 5, before you really start to notice changes coming back to the landscape.
Yeah, that lines up with what I've seen. I would say it was around year 3, like the end of year 3. You could see it by the fall of year 3.
Okay.
And like by no means, like I've got a lot of land still to manage and change, but you can start to see like the amount of dragonflies and how quickly manure is getting broken down. All those things that suggest that like the ecology is changing.
Mm-hmm.
And of course, this is like totally like just based on vision, not like any actual assessments. But yeah, I would agree with that in my own personal experiences.
Yeah.
Even anecdotally, like just walking around these different pastures, they're so different. Like the ones where the ranchers are rotationally grazing, there's just the flower community is so much more intense and more diverse. And like we do transects and we set them out and walk along them and count. And I'm always excited about those because we're actually going to find some cool plants. We're going to be like, oh, I've never seen that before, or I have to learn that plant because it's like it's new.
Yeah, that's awesome. That does bring up another question. Like most farms are basically like seeded based on like probably 100 different varieties, but realistically, most farmers are only running about a dozen different plants between forbs and grasses. And obviously, for 95% of the United States, those are not native species, or they've been improved. So they're not like natural native species. So when you talk about like this diversity coming in, obviously that means that's not a part of that 100 or so or dozen or so plants. What are your thoughts about how that's happening? Like what is happening that's causing native plants to, or even like regionally native, maybe not native, given climate change and all this other stuff, but these new plants to enter an ecosystem where you haven't explicitly gone and added these seeds? I know that's a big question to ask. I'm just curious.
I mean, we do see like if we burn our prairie, we see the natives just kind of pop up, or at least a lot of the flowers and the forbs. So it's sort of like that management of the grasses that are kind of staying in the way of everybody else.
So you think it's like a seed bank thing?
I think there's a lot, at least in our prairie systems, there's a lot in the seed bank. But so I guess, maybe you could reword the question a little bit for me here.
Sure. So you guys are talking about the fact that when you start mob grazing or holistically grazing, these pastures are going from like a half dozen, red clover and Timothy grass or whatever they're growing. And then you're starting to see these new species that hadn't been there before. So where are they coming from? If, basically, I'm assuming that most of the farms you're working on are like in areas where everyone has a farm and they're all growing basically the same thing. What's driving that diversity? Like where are the seeds coming from? And I think the seed bank is probably a big piece of it, but they've always been there. So is it just the additional nutrition that's giving them that opportunity? The grazing cycling itself, something about the way that they're I don't know. I don't know if anyone on Earth at this point has an answer for it, even though people keep seeing it. But since you guys are doing a lot of research in this area, I'm really interested to get your thoughts, even if it's not like statistically verified at this point.
Yeah, well, I can speak anecdotally about it quite a bit from what we've seen visiting a lot of places here in the Northern Plains. Yeah, the seed bank plays a lot of it. There's a lot of things that are they're either growing out there or waiting for their opportunity to sprout from a seed. And with some of these rotationally grazing, mob grazing practices, essentially you're cutting back evenly the potential invasive competition for them. So that allows an opening for some of those natives to be a little more competitive across that landscape that are just there, but you're not really noticing because there's just one of them out there. And it keeps getting nipped off right away because the livestock likes that one. It's very palatable to them. So there's some of that, and then that gives them room to expand more within that system. And a really bizarre, kind of interesting thing we've noticed a lot when I guess it's not that bizarre, but we've found a lot of our natives, they're really tailored towards certain little microclimates within those grassland systems. For us here, side hills. If you're on a side hill, you're going to get a lot more natives. And where hills maybe come together and there's a little gully or something between them, we see a lot more invasives. Or like in the flat bottom ground, we see some more invasives. For us, it's a lot of smooth brome and Kentucky bluegrass. And that might be because it's wetter there and the natives are more tolerant of those drier climate or microclimates on the side hills. So they can outcompete the natives or the invasives, excuse me. And it might be there's more nitrogen or something like that available there that the natives don't need as much, but the invasives can really take advantage of and outcompete them in those little micro environments.
Yeah.
And so by your rotational grazing, you can essentially pick and choose the winners and losers out there and really set those invasives back and let the natives flourish a little more.
Yeah, we recently, well, when this episode comes out, like 9 months ago, I had a guest on, Dr. Lynn Hunsinger, who's been working with basically grazing and trying to bring back a lot of native species in California. And she was talking about this idea of like grazing as a tool to reduce invasive pressure because the native grasses grow a lot slower. But once they're kind of at equal footing when they're a little bit older, they tend to be able to beat out and grow faster on that second half of their growth cycle, which makes a lot of sense because most invasives, especially in like pasture lands, like you're talking about like Kentucky bluegrass, they're designed or been bred in some cases to be fast early growers because the plan was to harvest them early anyway. So is this something you're also seeing, that like that chopping in the mob grazing is giving those natives some chances to get into that space?
Yes. Short answer, yes. That's what we're seeing on a lot of our regenerative holistic pastures. But I should mention it's a little bit more than just the grazing. A lot of the folks we're working with, they're using that grazing as a tool in tandem with other things like biological control, with using insects, or they might be using multi-species grazing, here sheep a lot of times. So if we would kind of take the leafy spurge as an example of this, I've had ranchers that can use that grazing to control leafy spurge, which is a big invasive in our part of the world. But it works a lot better if you integrate in some of these spurge beetles and move those around, or you do some multi-species grazing with sheep because they'll eat a lot of spurge more than cattle will. There's a great thesis out of North Dakota State, Jasmine Cutter looked at. It was kind of interesting how this multi-species grazing with sheep and cattle can affect floral resources for bees and butterflies and that diversity, just to kind of bring this back to the bee point. And they found there was in the sheep grazed paddocks, there's way less floral resources, and the cattle grazed ones, as an effect, had 3 to 16 times more native bees in them.
Which makes a ton of sense considering their preferences,
Yeah.
like what they want to go out there and eat.
So it's both good and bad. So you have to look at what's your invasive community out there and what you're trying to encourage with the natives. And if you're trying to encourage a lot of native floral resources, well, maybe then the multi-species grazing with sheep maybe isn't the right one for you. But
yeah, or maybe just graze them very long periods of time. So like 100 days versus like going through 3 times a year.
Yeah, exactly. So it's a bit more nuanced than just I'm going to put on some mob grazing and it's going to work exactly how I want it to. You have to kind of understand a little bit how the grasses and those forage and what you're trying to manage for works.
Yeah, you have to be, I mean, it's very holistic. And I know that's why the term holistic grazing exists, but it's very much like within the context of your location.
Yeah.
I guess to tie this back to like bees, like you were saying, theoretically, like sheep are not necessarily good or better than cattle when it comes to like trying to produce more flower content for bees to harvest.
Yeah, if you're just managing for pollinators, then you're trying to keep as many forbs and flowering plants as you possibly can. And for throughout the entire year, you know, have some resources for all year round up until winter.
Were there any like surprises that came out of the research? Like I think a lot of people that are interested, and I'm assuming even with the baseline knowledge, or I don't want to say baseline, with the knowledge that you have going into this, were there any real surprises that you're like, I did not see that coming, or like in retrospect that makes a lot of sense, but at the time like I hadn't put these two disparate pieces of information together?
I think for me, I ended up with just like way more questions than I did before I had this study, before I started it. So now, and like even your question about where did the flowers come from, like that's kind of blowing my mind right now. And I'm thinking about onions. I'm like, where did the onions come from? Like they must have already been there, right? Like it's an onion. So I don't know. I think I just have more questions.
That's awesome.
You did notice there's a lot of like there are some weird things that happen on some of our conventionally ran.
Yeah, like we started noticing invasives on the conventionally managed sites, you know. So there's like way more thistles and way more spurge. And then even at the spurge site, I noticed that the bees were not doing that great and the ants were kind of like dominating all the spurge. So it's almost like the bees weren't getting access to it. I don't know. It was really cool, really interesting.
But you can get these weird quirks on those conventionally managed sites where you get these huge blooms of an invasive. Mm-hmm. And you normally you're like, oh, invasives, but sometimes it was maybe to the bees' advantage, which is a weird quirk, but it's like one mass bloom all at once for them. Yeah. And then it's done the rest of the year.
And that has a lot to do with stocking density too. So you could have a lot of flowers if you I don't know as much about it, but if you don't put as many cattle out and kind of let it rest a little more. So you could have like a conventionally managed system that still has a lot of flowers.
Yeah. I mean, again, it goes back to what that local ecosystem looks like, and especially with invasives. Like here, we have a lot of Japanese knotweed, but it also flowers late into the year, which is great for bees, even though it's like an objectively terrible plant for our ecosystem. But it doesn't. And again, I think this speaks to like a lot of things. It's never as black and white as we try to pretend that things are. It's much more complicated than that, and we have to do a better job of acknowledging when these like exotic species come in that they're not purely bad. It doesn't mean that they don't have problems, but it's more than just being like this is an all negative thing that's happened.
Yeah, it comes back to that question of like, what are you managing for? If you're just managing for natives, which natives, and how long ago, what ecosystem, how many years ago was it perfect in your brain, know?
Yeah, and how does that fit into climate change where the ecosystem that existed really can't exist in most places?
Yeah.
So it's a difficult, challenging question, but I think a lot of the work, like what you guys are doing, is really important in kind of figuring out and navigating a way forward, because you need to understand the relationships, which we really in a very fundamental stage compared to like a lot of other sciences. And I think in order for us to kind of get ahead of the changes coming with climate change, we have to have a much more thorough understanding of these relationships.
Yeah, we have to understand it. And right now, I don't really feel like we do.
Yeah.
That's pretty interesting.
Ryan and Katya, this has been great. Can you guys plug where you guys work, or if you want to plug some other projects, I'm happy to send some folks your way.
Yeah, so we work for Ecdysis Foundation. We do mostly insect-related research in regenerative ag and sustainable agriculture. And we're starting a new project called the 1,000 Farm Initiative. It's supposed to be, we're trying to make it like the biggest sampling of farms for diverse communities and insect communities that has ever happened, pretty much. And we're trying to go all over the United States and sample 1,000 farms, which is a huge step up from what we've been doing lately. Yeah, so we work for Ecdysis Foundation, and we have a really cool farm here that's a functioning regenerative ag farm. It's in the middle of like the Midwest, so we're just kind of surrounded by cornfields. And like you said earlier, like you're trying to stop the spraying from the road. We've got like no spray signs out front because we're literally the only place in the whole area that's like, please don't spray. And so, yeah, we've got a really cool farm, and we've got a research lab that's like in the farm. We've got llamas and pigs and chickens, all sorts of geese that are really violent, ducks, you know, the usual.
Yeah, they do that.
Yeah.
Yeah. So actually, before I let you go, now I got to ask about the llamas.
Yeah.
Why do you have llamas? Like, how is that fitting in? I know people graze them for like various reasons, but I'm curious why you guys have them.
Honestly, right now we have llamas because they're really cute. I feel like that's the main reason. They're just cute and fluffy. There's like some plans to maybe start making yarn with them and bring them out for grazing, but alpacas, yeah, we've got alpacas.
Yeah, and I know a lot of people that use alpacas for guard animals. I don't know if that's what you guys are doing with them.
Not yet, but I would be really surprised to see them attack anything.
I mean, they're pretty big and scary looking, so yeah. That's, I think, half of it. All right, guys, this has been great. Thanks so much.
Thank you.
Yeah.